Hey, what's up guys? So this video I wanted to do is about the Arduino, right? So what I have here is I have the Arduino Uno and I have the CH32V003 F4P6, which is our RISC-V microcontroller, right? And what I wanted to talk about is that, the Arduino Q release, this is the original Arduino R3. This is an original Arduino R3. I actually got this in 2011, 2012 thereabouts. And it was when the Arduino Uno R3 first came out. Now the chip on it, which is the this was the original chip that was on it, right? I blew it a while back, but I still kept it because this was the first AVR I ever used, right? It has a new chip in it, and what I have here is I have both the Arduino and the CH32 blinking LEDs. And what I wanted to do in this video is actually talk about how you could move from the Arduino to something like the CH32V003. So you may be asking, why would you want to do that? Why would you want to move from our lovely Arduino board here to something like this? And the answer is the Arduino Q, right? So Qualcomm bought Arduino, they have the Arduino Q. And when I saw OG, right, like Paul McWhorter, that is one of the guys, top tech boy, he really pioneered after the Arduino tutorials and stuff. Like he said, this Arduino was a dream. Before the Arduino, I actually used pick devices. I used the basic stamp as well. And this Arduino platform, really made me appreciate how easy it could be to program microcontrollers, right? And, somewhere along the line, stuff changed, Arduino started to get more and more surface mount. And at the point now where you have the Arduino Q that you can't even use it. I mean, this, the chip on this blowout is able to change the chip. You can't do that on these newer boards, right? So what I wanted to show you is that, these two devices, they may seem different, but they're actually very, very similar. All the stuff I've set up here, right? Everything is on the board. That's why I say it's the same, right? They're actually running, two of them running Blink programs. I have it's off the screen, but there's a voltage regulator here, and then we have the programmer, and we have the microcontroller, the LED, and some passives and stuff. And it's the same thing we have on the Arduino board, right? So that's the first step. The first step is realizing that what the Arduino did is the Arduino took this here and put it in the easy to use board. Now, that was revolutionary 15 years ago, right? But we're at a point now where this chip is actually 10 cents. This original board was like, about 20 US when it first came out. I can't really remember. But, it was some dollars as well, right? And I reached a point now where it's actually cheaper. You can get this whole setup, for the price of our board, for like, $7, you could get like 50 of these, right? And it's like a totally different world out here. So let's look at how we could get started with this. So the first thing I want to talk about is the programmer, right? So if you're dealing with these RISC-V chips, you need to get an external programmer. The Arduino has the programmer. You see, this is the USB cable that comes in, and this little chip here, this little serial to USB chip here, is what actually allows us to put the program on the chip, right? In the case of something like the CH32V003, we have this, instead of having it on the board, just think of it like being external to the chip, right? This chip in particular, I'll show the connection in the video here. It has the 3 wires, so you need your reset line, you need to have your single wire debug line, and basically a ground connection. So the PC needs to share a ground connection with the chip, right? The only other thing you'll need is your passives, and you need to connect your your power. It's just 2 lines of power, and of course these devices run from 5 volts straight down to your 3.3 or 3 volts. It goes from really low, so you'll have no problem. With that. So this is it for hardware setup, right? Just like your Arduino, see they're both blinking the LEDs. But that's the setup you will be going for. So the only other difference with these two boards is that this is actually a proprietary 8-bit core, and this is a 32-bit device, right? This device is like 3 times more powerful in terms of core. It matches on SRAM. It matches it in terms of peripherals, and it's a better overall deal, right? So enough about hardware. I actually have a link. I'll put the link in the description where you can actually link schematics and the comparison between the two. What I want to do is we need to start looking at the the software, how you actually write programs for this thing. So you connect your programmer, you have your LED hooked up, from your pin. Even in the guide, I'll link a guide. In the guide you'll see if you never dealt with this before. And this is what you have. This is all you need to have. And from here we'll actually start looking at programming this chip. So guys, that brings us to the software, right? Which is where we'll be spending time writing, code for this thing, software for this thing, or firmware, or sketches, or however I call it, right? It's just firmware, right? So, the biggest change you'll encounter is the Arduino IDE versus just new MounRiver Studio. So this looks really daunting at first if you're not sure what all the buttons do, especially if you come from an environment like the Arduino like this, and it may seem really like it's really difficult to wrap your head around everything that's going on, right? The screen looks really busy compared to the Arduino, right? A really, really busy screen. Um, so the first thing I wanted to do is you'll want to get rid of this window, right? So this window here. Let's get rid of this now. The Arduino does the same thing everything is doing here, but it happens under the hood. So for now, we could just ignore that. We could just ignore that part. So you'll do window, and you'll just you get rid of the Explorer panel. So just like the Arduino IDE, you have your main window where you actually put your software, and you have your output window, right? So when you run code, you run stuff, this is where you'll be seeing any errors or anything that's happening. Um, this IDE is called MounRiver Studio 2, and it's actually based on Visual Studio IDE. And if you're in the embedded industry, you'll really appreciate that a quality IDE like this is given for free. I really appreciate it. A lot of people appreciate it. Now, what you want to do is, I want to show you an empty project. So this is an empty project, right? You just have to include at the top. So the Arduino is doing this, behind the scenes as well. And what this file just has register definitions, right? And the register is just a location on the device. I have a little guide I'll attach, the guide that will explain all the labs and stuff. So if you want to see what this look like, you can actually right click, and it can actually go to the definition, right? And in this definition file, you see all the stuff that file is including. You see stuff here for HSI and HSC. So that's your oscillator, your crystal, right? HSC stuff. You see in peripheral libraries. You see in interrupt stuff. If you come from Arduino, these words will make sense to you. The software itself may not, but you know what's an ADC, right? You know what's I squared C, SPI, what's a timer, right? So, that's what those stuff includes. It includes software that the hardware needs to run, right? That's all this is doing. Now, your init main is similar to your setup. So this code in the init main will run once. And it's just like the Arduino setup. There's literally no difference. Except that you'll see the empty version of this has two function calls here. And just know that they're for dealing with, hardware upkeep. So with the clock, so we could even go to definition, right? And that's what I really like about you'll get to appreciate this platform. Every single line of code, every single function in context will actually go and see what it does. So this function actually updates the core clock, right? And we don't need to worry about that. All you need to know is that okay, the core clock is being updated with this, right? And you also have a setup code here, and what is this doing? So we could go to definition and see, and this has something to do with configuring preemption priority and sub priority. So we know this is something with interrupts, right? This is actually a nested vector interrupt controller, NVIC or NVIC, right? We don't need to dive into this now. We just know that we need to include it, right? So every program will have our include init main, and we'll have these include functions here. Now we have main, and in main, you see init main, So we call any function. Now the difference is this is happening behind the scenes on the Arduino, right? So on the Arduino setup is called, but it's happening behind the scenes. Here you must, explicitly call it with any, you think about this like your looping function. But in this looping function, so the actual loop is taking place here. This while one is the same as the Arduino loop, but this part here, this main and init main and all these calls are usually hidden from you, right? But you get to see it, so you get a lot more understanding, right? And then from here, we see we have this while one is actually where we put the code that loops. So this is your blank canvas. This is where you'll be doing everything. So, we could look at compiling and writing stuff, but what I want to do is, let's see what happens when you build. So I'll close this. We'll build the project, right? So you see, this build notification stuff, and then you see this output, right? Now this output is really important, and it tells us a lot. So this text here tells us the code and read-only constants that are stored in Flash, right? This data section here is for, our initialized global and, like static variables, things that we store in RAM and Flash. So this is stuff that we store in Flash. This is stuff we store in, RAM and Flash. Now this BSS, right? This is, uninitialized global or like static variables. And these are allocated in RAM, but at startup, they are like zero initialized, right? This deck you see in here, deck is actually stand for decimal, right? And it's the total memory used in decimal, which is, um, you know, text plus data plus BSS. And this hex here is actually the total in hexadecimal format, right? And what this is telling us is the amount of memory our program is using, so you can add up the data and the BSS, right? So it's like 284 or so bytes of memory, right? And usually after we build the program, we download it. But since it's an empty program, if we download it, nothing will happen, right? So we could actually do that. You could actually download it. So you'll build project and download it. And you'll see the program on Flash, and that'll be it, right? Your chip is totally blank because it has nothing on it. So what you want to do is you actually want to run a program here. So I'll actually input, blink here, and I will, also show you the Arduino minimum blink so you get an idea of how it works. So what I have here, we have the Arduino. This is the blink program, right? That everyone knows. And on, the right here, I have this program that is from WCH. So we have Arduino program here, and we have our WCH program on this side, right? And what you'll see is that we start the same. So we have this description section, right? Arduino, the Blink also has it. It's a comment block and tells you who the program was written by, right? And the date and information, stuff like that, right? And license information and things like that. So that remains the same, right? You move down a little and you'll see we have no includes, but we need to include. This is an include we need to have, right? And you will see we have the setup. So in our setup, you'll see the code we are custom with, and you'll see this delay init. And what this function does, this allows us to use delays. So in the Arduino, you see you have delay 1000 here, right? If we look on this side, we see that we also have delay functions, right? We also have delay, but the delay is in this init main, this delay init, right? So it's the same. It's just that we need to call that, right? We also have, and you can think was like another setup. This is to initialize the GPIO. So we're doing a lot of stuff here. The guide will go into more detail, but essentially what we're doing is we setting, pin D0. So we could take a look at the, I have it here. So this is pin D0, right? This is the pin we had the LED connected to, pin D0. I don't know if the mouse is showing it, but this is pin D0 here. and this is what we'll be actually controlling. So there are some stuff we need to do. We need to initialize our structure, enable the clock, select the pin, set the pin to push-pull mode, set the output speed, and apply the configuration. Now, at first, this may seem like it's a lot. After all, we know you just have to set your stuff high or set it low, right? But this is a lot more power at being able to adjust your output speed of your pin, being able to, manually go in there and select the mode that your pin is using. The type of clock and things like that is a really powerful feature as you're going to appreciate. But for now, um, just know we need to set up the pin that we're using. So the most important ones in these is the clock. Make sure you see the clock for GPIO D, which is pin D. You see, we select, pin 0 from that. And, then we initialize it with the structure we have at the top here, this GPIO structure. We set it to like this is a null. And then we just, we apply it, right? Now the actual, blink LED, right? So this blink LED, so we function it out. So in the Arduino code, it's actually in the loop and it's inside, but it's the same code. But imagine if we pull it and put it in another function, and that's the same thing we're doing here. So we set the pin low, right, for 250 milliseconds, then you set it high for 250 milliseconds. And the nice thing is like when you hover over this when you hover over these functions, it tells you it's a function. It tells you the parameters. It tells you some of the stuff from the docs, right? From the docs that built in, right? And you could actually, you go to definition here, and you actually could see, all the documentation of it is a function, what it does. The registers are being toggled, so, you get a good understanding of what is happening inside the chip. Now we on to main. And in main, we call the init main. Remember init main, that's how that come like our setup, right? So that's our setup here. And then we call the initialize GPIO, right? So this is we initialize the GPIO pin here. And we don't need to, have everything inside here like in the Arduino way. We just call a function with it, right? That's all you have to do. And when you click build project, make sure everything builds. You'll see the memory usage here. So you can calculate your bytes, right? And then you will, build the project and download, right? And what this will do is it'll rebuild and download. If you just wanted to download the project, you'll see the download button. You just click the download button. So usually you'll have your screen expanded like this, and you'll see this download button here. This is actually what you'll click. It wouldn't build the project in this case. It will just re-download the hex file. You could also debug, right? If we set up debug breakpoints and stuff like that. But that's generally what we need to do. 90% of the time, as a beginner, you'll be working in this window here, and you'll be, building, rebuilding, downloading, right? So just focus on this, this area here, this section, right? When you do need the window, what you will do is you'll go to window, and you could actually, you know, put all the other windows and tools and whatever it is else you may need, right? So we open up the Explorer panel, and that's all we need to do, right? So I actually have an entire guide. Thanks for watching. I have an entire guide that walks you through not only blinking LED, but everything you're accustomed to the Arduino, your setups, your loops, digital write, digital reads, your watchdog timer stuff, all that stuff, how it is we do it on the CH32V. It's very simple once you start getting the hang of it. I have it's available. It's free. I'm not charging anything for it. It's a GitHub. I have a website set up where you can actually go and get access to these resources for free. And all access that you give my like, give my sub, um, and you get working code. The project all you do is download MounRiver Studio 2, right? Let's see which version this is. So this is version 2.3.0. So once you use 2.3.0 and usually above, you should be okay, right? And even 2.2.0, you won't have any problem. So download the IDE, open the project, you'll see the blank project. You see all the code example as text, you just copy and paste it in, watch it, understand it, you can dig around, don't forget. Anything, you could just right click, you go to a definition, you see documentation for what it does. So nothing is a mystery, right? And you know, if you come from the Arduino background, you have um some experience programming in C. So that's it, guys. Thanks for watching, and I hope to see you on the next video where we might dive into some other stuff, depending on the feedback. And good luck in moving to RISC-V. Thank you.